The next topic is extrema of polynomials. Now, extrema, as you can see, is something extreme. It can be a relative maximum or minimum. It either is topmost or bottommost, extreme points, as you can see over here. Now, this graph is like a cubic graph, it will extend forever. So don't see the last parts. See this part, the minimum most point comparatively. So it's called relative minima. And over here, this is relative maxima. As you can see, point A is relative minimum and relative maximum point is B. So these both points are extrema. Again, I repeat, please don't see these points, the line where it extends forever. And these are also called turning points. Why? Look, the graph over here was going downwards and it turns and moves upwards. See, decreasing, and over here at point A, it increases and again decreases after point B. So they are also called turning points. Now, how many of these turning points are there? Or extremas are there? Now, if you have a parabola, let's say this is x to the power 2. Now, what happens is, you can see there is only one. Now over here it's cubic, there is 2. If you go to another like this, x to the power 4 graph, it might be 1, 2, 3. So this is x to the power 4, okay? What you can see is, if the degree is n, that is any number, n minus 1 will be the maximum utmost. Utmost is maximum extremas. It can be less than that as well, but it can be only maximum up to n minus 1. Now we will see a problem over here. Identify the extrema. We have this function. We need to use the table and graph this and estimate the x coordinate at which the relative maxima and relative minima occur. Now, it's very simple. You need to make a table of values. So what do you do in the table of values? Take some random values. Now this is a cubic. You can see it's cubic graph. So x to the power 3 is the degree. So take values from some values less than 0 and greater than 0 and find it out. Now all you're doing is, we just did this in the last problem. The same thing is repeated. So I won't go again and again, but you need to try it. Pause the video and try it by yourself. Put over here minus 4 instead of x. Now, if you just put minus 4 power 3 and minus 4x power 2 and so on, you will get wrong. You need to use the brackets when you solve, okay? And over here as well, minus 4 the whole power 2 minus 5 multiplied by minus 4, and lastly we have minus 2. Use the brackets, otherwise you won't get the correct answer. If you put this exactly in the calculator, you will get minus 30. Then just change the 4 to 3 and find the other values. So now you will get the function, the values for this function. From here, you can understand that there is negative and positive values. These are the changing points. These are the uh, we had seen this location from the location principle. These are the solution points. Over here, the solution exists. But anyways, let's see the problem now. See over here, minus 3, that is minus 1, minus 2, minus 3 to minus 2, you have the solution points over here. But now they have not asked you this, but if at all that was asked, this is how we solve it. It's always good to know. But now what do we want? We want the maxima and minima. So see, it goes up, it goes up. Then you can see over here, there is a turning point. That is this somewhere over here. So the extrema, it's around, the maximum value. See over here from this table, you can just check which is the maximum point. Minus 30, minus 5, 4, 3, minus 2. See, this is one of the relative maxima, isn't it? See over here, this, where is it? Minus 2 f of x. Why is 3 not maxima? Because in the graph, we can understand, from the graph, we can understand this is x to the power 3. So there is two turning points. Now you're not taking x3. Why? Because this is going towards infinity. This doesn't matter. This is not the maximum. This is not relative maximum. This is relative maximum. That is at around x minus 2. It is not accurate, but around x minus 2. If you want accurate, you can even start plotting zero point 0.5 and you can see zero point 0.5 would be more accurate, minus 2.5. Sorry, minus 1.5, I'm wrong. It's minus 1, 1.5 would be the maximum. Now, what about the minimum point? Minimum point is accurately over here at 1, so that is the minimum point. So this is the maximum and minimum point. Over here, you can, I mean, it's asked to estimate, it is not find the exact maximum or minimum point. So these are the estimated values. So now depending if this comes in the MCQ, depending on the options, after graph, look at the options. If the graph is given, it's very simple to find. Otherwise, look at the options and solve. I hope you remember the table of values. We have already done this. This concept is very important and we have to do it many times. Now over here, we have another problem. The total number of certified pilots in the United States is approximated by f of x equals this old function. It's a huge function where x is the number of years after 1930 and f of x is the number of pilots in thousands. Graph the function and describe the key features over the relevant domain. What this means is they have given this function and told from 1930 this function can be modeled from 1930. If we make a table of values, now we will generally make a table, say it's from 0 year, 10, 20, 30, 40 and so on years, right? But you must understand the zero. What is the zero? Can anyone think? Take time, think, and understand. In this context, this 0 is 1930, year 1930. What about this 10? X is in years, right? Sorry, over here. X is number of years, isn't it? 10 means 10 years after 1930, that is 1940. And so on. You will go to the next years. So if you sketch the graph over here, so though we write 0, you must understand this is since 1930. You can't take the domain 1930 at once, it will be too much because this is, see, x is years after 1930. If you're taking 0, it's 0 years after 1930. Then 10 means after 1930 and so on. See, this is how it goes. So if you find, you can understand the number of pilots started increasing after 1930 until over here. Then they went down and then again they went up. So that is the graph, approximate graph, okay? The domain and range are all real numbers because you can put any function, any value over here and you will get an answer, isn't it? But no, this is not the case. See, over here there is domain and range, but in reality, you must understand what is the x value. It is after 1930, so the relevant domain will be only values after 1930. You can't take and predict anything before 1930. That is the crucial part over here. Because they have mentioned it's only after 1930, it should be values only greater than or equal to 0. But this is very important. X is after 1930 values, 1930 year. And similarly, which is the least value at 0? It's 7.7. So there can't be any values less than that. So the starting value is 7.7 and it's greater than that. See, is there any less value? No, because this goes on upwards. So this is the concept over here. So if you mention this, it's enough x, but the domain will be greater than or equal to x, okay? Because you can't go negative left side and the values of y is always greater than or equal to 7.7 in this particular case. So that's the thing. And they told to find the extrema. Now, what about the extrema? Extrema over here, you can see, is somewhere over here, right? So that's about 50 years. Now, they have told 1980 and 1990. Why? Because if you look closely, it is after 50 and less than 60. See, it's somewhere over here, isn't it? 50 years means, over here 50 means, it's 50 plus 1930, that is 1980 and 1990, in the year 1930 and 1980 and 1990. So that is maxima, and minima is over here. Similarly, add 80 to this. It will be 2010 to 2020. say the least. So this is the minimum point. And end behavior, as you can see, as x is going towards infinity, this also goes towards infinity. Okay, that's the end behavior. And now you're not going to take the left side. Why? Because that is not in the domain. You cannot use this equation for the left side. It's only for the right side values. And now over here, there is no x-intercept. Why? Because if we go over here, is there any f of x 0 over here? No, it does not touch the x-axis. It's little more, right? So there is no x-intercept. X-intercept is the value that touches the x-axis. Okay, it's only the y-intercept there is at 7.708 that we found out in the table. And this has no symmetry at all. It is just there's no symmetry. It's not same both the sides. See, it's just like this freehand graph. So this is the answers. So, sorry, let me stop over here for now. So this is the type of problems about relative maxima, minima. I hope this is clear. Try to solve similar equations. The most important thing over here is always this table of graph. Okay, sorry, table of values. From this you can graph it, and then you can easily find the maximum minimum value, and you can understand what it is based on the question. Over here it is values more than 1930 and so on. So if you have been already given this table of values, you have to just graph, or if the graph is already given, then it's well and good. Then you can easily find the extrema, intercepts, and behaviors.